Okay, guys. So, last class we were talking about, get this all fixed up here. We were talking about some math review. I believe the last thing that we talked about was units. Is that correct? I'm pretty sure. Yeah. So anyways, what we're going to get into now is a technique called dimensional analysis, which sounds kind of like wizardry, but I promise it's actually a lot simpler than it sounds. Okay, so first things first, what the heck does the word dimension mean? It's basically just a fancy way of saying a unit, right? Analysis means we're using the units to do all of the analysis and the problem solving, okay? So the next thing we want to talk about are conversion factors. Conversion factors. Now you guys are probably familiar with these. You've seen them before, but I'm guessing that for whatever reason there's no succinct way that math talks about conversion factors, and so they make it kind of mystifying, I think. So basically what a conversion factor has is the one of some unit and what that equals in terms of a number with the other unit, right? So for example, if we were talking about 1 dozen, right? What would that be equal to? Say 1 dozen eggs. 12, right?
12 units.
Exactly, right. So that's a type of conversion factor. Another one is, let's say we're talking about 1 mile, right? We could convert that into feet. I'm guessing you guys don't know this one off the top of your head, but because I'm a crazy person, I just happen to know that it is 5,280 feet. Everybody comfortable with these? You've seen these before. The big question that usually students are immediate to ask is, will I have to memorize these? And the answer is no, okay? The only conversion factors that you guys will need to know are these metric conversion factors, okay? So if we're talking about non-metric, pretty much any kind of American unit, you will not need to know those conversions. I will give them to you always, okay? You do, however, need to know how to use those conversion factors, and that's what we're going to talk about with the dimensional analysis problem-solving technique, right? So let's just look at this conversion factor chart and talk a little bit about it. So we talked about units last time. We said meters. Meters, that's one of our base units. What does meters measure?
Length.
Length, exactly, right? Everybody comfortable with that? Cool. Liters, what is that?
Volume.
That's a measure of volume, and grams is mass, right? So these 3 units are what we refer to as a base unit, because the all of the other units are just placeholders using this base unit, okay? So they're essentially factors multiplied by or divided by the original base unit, right? So relative to our base unit, if we jump up 1, we get to kilo. So let's say we're talking about liters. It would be 1 kiloliter. It's not something we use very commonly, right? But you could see it. 1 kilo is always 10 to the 3 of the base unit, right? So in terms of liters, we have 1 kiloliter is 10 to the 3 liters. 1 kilogram is 10 to the 3 grams. 1 kilometer is 10 to the 3 meters, right? Now, 10 to the 3 is another way of saying what?
1,000.
1,000, exactly. Is everybody comfortable with that? Cool. For base units, obviously it's 1 to 1, right? And then when we jump on the other side of that, we get to centi, which is 10 to the 2 of these little guys can fit inside of one of the base units, okay? So here, over on the top, we had the 10 to the 3 on the liters side, right? But now we're putting that big old number on the other side, right? Now we have a 1 where the base unit is, and 100 of the centi guys. Does that make sense? You picking up what I'm laying down?
Quick question, Danica.
Yeah, go ahead, Troy.
Are we going to want to learn the full scale of conversions from deca to macro all the way through?
No. So that's a great question, right? So there are unit, there's other steps involved in the metric system, but we're not going to use those, okay? If I ask you to convert with those, I'll give you what they represent, right? So it's a great question. Yeah. Any other questions? So these 4...
Sorry, wait, sorry, this is kind of off topic. Is this following the textbook, or are you just teaching like whatever you want to teach?
the textbook will follow more closely once we've gotten through some of the basics.
Oh, okay, so we're not in the textbook yet.
We might be loosely jumping around to the textbook, but we haven't started talking about atoms, elements, compounds, things like that, right? We're talking about dimensional analysis, and we're talking about measurements.
Okay, for sure. Okay, thank you.
So,
I have a question.
Go ahead.
So I noticed on Canvas where it says upon mastering this chapter, you should be able to. So.
You mean that?
So this table on Canvas for the micro units, the abbreviation is M as well. So like it's both M for milli and for micro instead of U.
This is M, and this is mu.
Right. So the mu is not there on Canvas. On Canvas, it's just an M.
Maybe Canvas won't let me do that. Ooh. Well, it's definitely mu. That's okay. I'll look at that. So, unfortunately, one of the things about posting this stuff in Canvas is, especially with symbols, Canvas does not like symbols. So yeah, let me see if I can fix that. I should be able to fix it, but thank you for pointing that out to me. Yeah. So just so everybody's comfortable here, this is baby K, baby C, baby M, and mu, which is a Greek letter. Okay. Baby M for milli. Baby M is also for meters, right? So there's a lot of things that baby M counts for. It's very confusing, right? So you've got meters is baby M, milli is also baby M, mass is often used as baby M. There's even more than that, and it's very annoying, but hopefully contextually you'll be able to figure out what we're talking about. So, anyways, getting back to which ones you need to know. Only ones that you need to know are kilo. There's 1 kilogram or 1 kilo for every 1,000 of your base unit, right? And there's 100 centi for every 1 of your base unit, 1,000 milli for every 1 of your base unit, and 1,000,000 micro for every 1 of your base units. Does that make sense, guys? We cool? I'm sorry, you guys. I thought putting my phone on nighttime would make it not have messages pop up for you guys, but apparently that didn't work. Cool. Everybody.
Sorry, did you say milli was 1,000 and micros how much?
A million.
Okay.
Yeah. Yeah. AKA 10 to the 3 or 10 to the 6, respectively. Mm-hmm.
What was centi again?
100.
Oh, yeah, that makes sense. Sorry.
Yeah, like a century. Millennium.
I know it says it in like the second column, so so like milli would be referring to like from the base unit, and so I'm kind of confused. What I know kilo is like 1,000, like 3 zeros, but I guess I've seen it before written as like a negative 10 to like the negative power, not as kilo, but the other ones.
Right. So, okay. So this is a great question because you'll see different tables are written different ways. So there's 2 different ways to write the same thing. So if I have 10 to the 2, let's say, centimeters for every 1 meter, right? There's another way that we could write this, which is for every 1 centimeter, there's 10 to the negative 2 meters. I personally find that students find this very confusing. So I always put it in this term in my tables. Okay?
Okay, yeah, that makes more sense.
But again, you'll see them written both ways, depending on which references you're looking at. So just so everybody's comfortable, these 2 things mean the same thing, right?
Okay.
Another way that you could write this, just so that we're getting our flexibility going here. So if I say 1 centimeter is equal to 1 meter over 10 to the 2, right? All of those are saying equivalent things. So, if all of these are saying equivalent things, it's really easy to flip these around, okay? So, here's what I want you guys to do. Kilo is big, okay? If kilo is big, it means that you're going to have a lot of base units in it, okay? Everybody else is small, which means that you're going to need a lot of them to get 1 base unit, right? Now you're probably going to have to repeat that to yourself 1,000 times before it sticks to your brain, but this logic, the logical approach to thinking about which one of these numbers should be bigger is super important when you're trying to remember something off the top of your head, right? Because it's really easy to F this up, I promise you guys. The best way that you can keep yourself straight with which one it is remember that this guy is bigger than this guy, which means you need more of this guy for every one of this guy, right? Does that make sense, guys? Kinda, sorta? Say, do you look angry? You cool with me?
Yes.
I'm angry, it's fine,
Cool.
ignore that.
That's okay, no, it's good. Anybody else have questions about those? Okay, so let's talk about using these guys. So let's say we have 15 milliliters, sorry. Come on. Focus, please. There we go.
Oh, like tap the screen maybe.
There we go. All right. So if we have 15 milliliters and we want to convert to liters, right? I'm sure that some of you guys are thinking, oh, I know I can just move the decimal place here. And I'm going to tell you forever for the rest of your life, we're not going to do that. So at some point you'll be allowed to do that again, but for now we're practicing a problem-solving technique that involves specific steps, okay? And that's dimensional analysis. So, for any dimensional analysis problem, we start off by writing whatever we're given, right? So we're given 15 milliliters. And then I lay down my railroad tracks here. And I know that if I have units of milliliters up top, right, then I'm going to want units of milliliters on bottom here to cancel milliliters, right? Because I'm trying to get into a different unit. You guys picking up what I'm laying down? Yeah? So, I want milliliters here, right? Which means what unit is going to go up top here?
Liters.
Liters, exactly, right? So, anytime you see a ratio like this, you should be thinking conversion factor. Right? So, what is the conversion factor that takes us from liters to milliliters or vice versa?
It's 1 to 1,000, right?
Yep, so for every 1 liter, we have 1,000 milliliters. Okay? And again, you may not know that off the top of your head now, but you're going to have it memorized soon. Cool? So, the 1 here belongs to liters, right? So the 1 goes up top there with liters. You guys with me? 1,000 belongs to milliliters, so that goes here. Okay? Is everybody comfortable with the fact that I'm going from this notation to this notation? Back and forth, they mean the same thing, they're equivalent. Cool. So, now I have milliliters on the bottom and milliliters on top. These guys cancel each other out, and we're left with units of liters. Okay? Now all we need to do is multiply the top number together. So I have 15 times 1 gives me
15 liters.
15 divided by 1,000, right? So whatever's on top will be multiplied together. Whatever's on bottom will be divided. You with me? Cool. I'm lazy and I don't want to put this in my calculator, okay? But I'll show you how to do it in just a second. So this is equal to 15 times 10 to the negative 3 liters, right? And again, this comes back to what we were talking about previously, where this 1 over 10 to the 3 is equivalent to 10 to the negative 3. Questions about what we just did there?
Make that true scientific notation. Like if this were a test, would we want to move that decimal 1 further?
So, for the first quiz or exam, if I'm asking you to put it in proper scientific notation, then you would need to change this, right? Is everybody comfortable with the fact that this isn't proper scientific notation? Yeah? So, proper Sci-No would have us move the decimal place over from here 1 place, right? Would that make the exponent bigger or smaller?
Smaller would make it -4.
-2.
Right?
-2, right? So think about it. 15 is a bigger number, right? So if we want to move the decimal place over once here, then this number, this exponent is going to get smaller, right? It's going to become -2. 1.5 times 10 to the -2 liters.
Thank you.
Yeah, totally. And again, this stuff, if it's not intuitive for you, that's okay, right? We're going to do so much practice with this stuff. That's why I get you guys moving with the math as soon as possible, because I think a lot of the chemistry concepts that we'll cover early on are pretty straightforward, right? This is usually where students have a hard time. Check into the chat here.
For the liters symbol, it would go at the very end of the entire scientific notation, correct?
Yes, exactly. Right here. Yeah, so that's another thing. Students sometimes will put the 1.5, then the liters, then the times 10 to the negative 2. You want to put 1.5 times 10 to the negative 2, and then liters. Yeah, great question. The question, what conversion factors do we need to have memorized? The ones that are in the what you should know on Canvas, right? So 1.1, I believe it is. Upon completing this chapter, you should know just those, aka the ones that we looked at in the lab manual, like just a second ago, or not lab manual, the lecture packet. Do you have to show all of your work in scientific notation? No. Only when it's specified, but it's pretty good practice. My rule of thumb is if you have 3 or more zeros that you're having to write out, that just starts looking really confusing and ugly. So put it into Sci-No. But I will be very explicit on quizzes and exams. Any other questions? Cool, let's do some more of these. All right, let's do stupid. Come on. Focus. There we go. Cool. So 13.5 is usually, for the average car, this is about the size of your gas tank, right? 13.5 gallons. And we want to convert it to milliliters, okay? So my first thing that I want to do whenever I'm looking at conversions that have multiple steps in them is I want to draw a map, okay? So I'm starting out with units of gallons, right? And I want to get to units of milliliters. Now, there's probably a conversion factor out there that can get you from gallons directly to milliliters, but I'm not going to give that to you, right? I'm going to give you the one that takes you from gallons to liters, right? So if I give you the one that goes from gallons to liters, then that means that you have to make the jump to know that from liters, you want to convert to milliliters. Does that make sense? Cool. So, conversion factor that takes us from gallons to liters, there are, for every 1 gallon, there are 3.785 liters, I think.
That's correct.
Thank you. And for every 1 liter, we have 1,000 milliliters, right? So, I set up my railroad tracks, right? And what unit it's going to go on the bottom here?
Gallon.
Is everybody comfortable with that? Gallons. If I have gallons on top here, I want gallons down here to balance. Or excuse me, to cancel.
gallons doesn't go underneath the 13.5 gallons. It goes on across from it.
Correct, because here this number is by itself up top, right? So everything that we're putting in there after is usually going to be a conversion factor of some flavor. Does that make sense, Angelique?
Yeah, so we're trying to get rid of it, right?
Yeah, exactly. Yep, we're trying to cancel out gallons, so we want gallons on the bottom, right?
Okay.
And so we know when we started out with gallons that we were going to have to go to liters first, right? So if we've got gallons down here, what's going to go up top? Liters. Everybody comfortable with that? So, what number... So annoying. I hope this calendar notification goes away. Oh, good. So, what number is going to go on bottom here next to gallons?
1.
1, exactly. And what number will go up top here?
3.785.
3.785 liters, right? Everybody still cool with me? Cool. So I have gallons cancels with gallons, right? Now when we cancel the units, we're not canceling the numbers, just the units. Everybody still all right with me on that? Cool. So now for my next step, I need to go liters to milliliters, right? So what unit's going to go on bottom?
Liters.
Liters. And what unit's going to go on top? Milliliters, right? So what number goes next to liters? 1.
1.
And up top?
1,000.
1,000, right? Liters cancels with liters. And so now we just need to multiply, okay? I'm going to show you how I do this in my calculator. Scooch it. So, if I had any numbers other than 1 on the bottom, right, I would need to make sure that I had parentheses around these when I divided. But everybody's comfortable with the fact that dividing by 1 is essentially the same as doing nothing, right? So really all we have to do here is multiply 13.5 times 3.785 times 10 to the 3, okay? So,
I like your calculator, Professor.
what's up?
I like your calculator.
It's pretty cute, right? I've got like 5 different colors of this calculator.
Yeah, it's pretty cool. Pretty cool.
Cool. And then if you're not comfortable putting 10 to the 3 in your calculator, that's fine. You could just put 1,000. But if you want to put it in just like we have it here, this little caret symbol, oh, you guys can't see me, caret symbol up here is going to represent the power. So this would be caret and then 3, that would be times 10 to the 3, okay? That's different from how you put in scientific notation though, okay? And so that gives me this gigantic number, which is really hard to look at. So I'd much rather have that in scientific notation. So if I go here to second, go to Sci-Eng, it has me in flow right now. I want to click it over to Sci, press enter, and now it gives me the number in scientific notation, which is much easier to look at. I think, hopefully. Anybody get anything other than that? Feel free to...
I rounded out to 5.21 times 10 to the 4.
5.11
Yes.
times 10 to the 4th. And then we never forget our units. Our units are so important. Milliliters. Questions about that, guys?
Quick question.
Yeah, go ahead, Brittany.
Is it good for us to always just round to decimal places or to the
So I as I've said, I would default to 2 decimal places, but I wouldn't mark you off if you had more than that, unless in a quiz or in an exam, if I explicitly ask you for 3 decimal places or something like that, then definitely give me that. But usually my default is 2 decimals. Yeah. Any other questions people have?
Professor?
Yes.
So just a quick question on memorization. Should I also, I know this might be a little bit premature, but I was looking through the stuff we should know. Should we try to memorize or start trying to memorize the conversions for Celsius to Fahrenheit and Fahrenheit to Celsius, or is that something that would be provided to us on a test, like that kind of formula?
So I'm never going to ask you to do that calculation.
Okay.
Basically, we're just going to kind of pretend like Fahrenheit doesn't exist. We haven't started talking about temperature yet, but once we do, we'll get deeper into that, right? So, but one of the things that I think is difficult for us, especially, did anybody grow up in a different country? Yeah, so if you grew up in a different country, then you're probably really familiar with what Celsius means in a more meaningful sense. So like if somebody said it's 40 degrees Celsius outside, is that hot or cold?
It's hot.
It's really hot. Yeah, it's very uncomfortable, right? So y'all don't have a lot of intuition for that. But one of the things that I usually recommend for students at the beginning of the semester is take like a couple weeks or a month and convert your phone into Celsius instead of Fahrenheit, and just feel what that temperature is like, right? Do you have to do that? No, but I think it's a really nice way to figure out intuitively what that scale kind of feels like. So, other questions about... Yeah. Other questions about dimensional analysis so far? What do you guys think about it? Stupid? Annoying? I love it?
Oh, Professor, I did think of one more question on the practice problems that you gave to us.
Yes.
There's I wondered if you'd be going over that one problem where it ends up, I guess, converting into joules or something. Will we be going over that one?
Sure, we can go over that one.
Oh, great, thank you, because I know I'm going to screw it up.
So, that problem in particular has a unit that we haven't talked about, but what I'm trying to get you guys to think about in terms of what a unit is that it doesn't matter if you know what it is, right? We could make up units, right? And I've been known to do that on quizzes before. I'll make up a fictional unit that has nothing to do with this, and I'll give you a conversion factor, right? The point is that it's not about knowing what that unit represents. It's about knowing that if you cancel everybody else, that's the unit that you end up with, right? So let's look at that problem specifically. Any questions about this one before I erase? Cool. Okay, so 626 times 10 to the negative 34 joule seconds times. Anybody taking physics?
A very long time ago.
A million years ago? Cool.
Yeah, I took it in high school 10 years ago.
So anybody
I took it in high school 2 years ago.
Anybody recognize this number?
Yeah. Wait, hold on. Move your hand, please.
Sorry.
Is that that's either Avogadro's number or the speed of light? I can't remember which one it is.
Definitely not Avocado's number, because Avocado's number is a lot bigger than that. We'll get to that. But this is the speed of light. You're right, Miles. Right? So, this is not a type of problem that you'll ever have to see or do. But this is a problem involving the wavelength of light and how you can solve for the energy associated with a particular wavelength of light. This wavelength corresponds to roughly the color yellow. So we're essentially calculating the energy of yellow light. So totally trivia, not something you need to know, but I like to use real examples when I can. Okay. So I would say, arguably for most of you, that putting the scientific notation into your calculator here is the biggest P in the A, right? So we can talk about that because I think that's really important. But just so we can see how these units cancel out, I'm going to write the units by themselves down below here, okay? So we have joule seconds, right, times meters per second divided by meters, right? So seconds times 1 over seconds. Does everybody see how that cancels? Anytime you multiply something by its reciprocal, it will cancel. Everybody all right with that? Cool. If it helps, we could always rewrite it like that, right? That would also be equivalent. Seconds cancels with seconds here. Another way that we could write this is we could just put seconds on the bottom there, right? Either way, they cancel. Cool? Meters is going to cancel with meters, right? And so we end up with units of Daddy J, which you don't know this, but it's energy, but it doesn't matter. These are joules. Joules. Got the joules. Questions about how we canceled out the units?
Is joules a unit of energy?
It is a unit of energy, yes. Yeah. Yeah, we don't deal with a whole lot of energy calculations in this course, but if you were going on to a different type of chemistry, you might see that again. Or physics would be another place you'd see that. Questions? We cool? Alright, so I think sometimes it can be helpful to deal with the units first so that you can just simplify the problem, right? Cool? So, the next thing that I would want to do is combine all of our powers of 10 here, right? So if you guys aren't familiar with this, I'm just going to write these guys all next to each other so that we can see how they combine. Right? So, when we have multiple factors that have the same base but different exponents, what can we do with the exponents to combine them? Go ahead, Mouse.
You can add and subtract them. If
Right.
you're multiplying them, you add them, and then if you're dividing, you subtract them.
Exactly, right? So if we're multiplying, then these two will be added together, and with division, they'll be subtracted. So when we combine this guy, we're going to have 10 to the minus 34 plus 8. Sorry.
Negative 26.
I'm going to do them all in one line because I'm lazy. And then minus 7, right? So when you have minus and minus next to each other, that gives you a positive, right? Everybody comfortable with that? So, overall, what does this equal?
To the negative 19th.
Mm-hmm. Questions about that?
No.
Cool. So we know that our answer is going to have this order of magnitude. Everybody comfortable with what I mean when I say order of magnitude? It's just a fancy way of saying power of 10, right? So the order of magnitude of this is 10 to the negative 19th.
Oh, okay.
Yeah. It's just a fancy way of saying it.
Will it go on the top or bottom?
So this guy is on the top, right?
Okay.
Because we moved the negative 7 up to the top when we subtracted it. Does that make sense? Yeah. Mm-hmm. So now the only thing you need to put in your calculator is this guy times this guy divided by this guy, right? I love you guys can see all of my notifications on my phone while we're doing this. Does it show up in the recordings too? The notifications? Yeah?
No, it doesn't.
Not on the recordings, I don't think, right?
No, not on the recording.
Okay, cool. Should make sure I'm not putting this out there for the world for the rest of all time. So what do you guys...
4.17.
4.17. Anybody want to back up Ross on that? Not because I don't believe you, Ross, but the more people get the same thing, the more I figure we're in the right ballpark. Cool.
Yeah, I got that too.
Awesome. Awesome. Okay, so now I just want to talk really quickly about how to put that in your calculator in scientific notation. The reason why I like to teach this method is because scientific notation in different calculators works different ways, right? So I'm going to show you what it looks like on my calculator, but that may not be what it looks like on your calculator. And it's super, super, super important that you are able to have an intuition about whether the answer that your calculator gives you is correct, right? So by being able to do something like this, as you're getting familiar with your calculator, you're able to kind of check your work, right? So personally for me, that gives me a lot more confidence when I'm on a quiz or a test, knowing that I can do this without a calculator, at least just to double check myself. So, looking at this in the calculator, I have 6.626, and I'm going to use the secondary function EE, right? So I go second, and then press the EE button. For some of you, it may look like something like that, right? Different calculators have it different way. What this little e means is times 10 to the whatever comes next, right? So I have negative is this symbol down here, right? Not the minus sign. 34 times 2.998 secondary EE to the 8th. All of that gives me 1.9 blah 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 times 10 to the negative 25th, and then I'm going to divide that by the denominator, which was 4.76. Yeah. Second EE to the negative 7th. Right?
Wow.
Now I could have put it into my calculator all at once. I would have needed to be careful with parentheses. Okay? Now, I just want to show you guys really quickly what it would look like if I did this incorrectly, okay? So don't do it this way, but I want to show you that we wouldn't get the same number. So if I did 6.626, whoops, times 10 to the negative 34 times 2.998 times 10 to the 8th. Ooh, this one was smart. It managed it. Okay. We got lucky on this one. Let's see if it works for this one. 4.76 times 10 to the negative 7th. Right? So you see, negative 33, that's not right. Okay? So what the calculator is essentially doing is it's dividing the first number that we got by 4.76 and then multiplying the answer by 10 to the negative 7, right? That's not what we want to do. Questions about this? We cool?
Thank you so much for doing that problem.
Yeah,
it was,
no
like,
problem.
Worrying me when I looked at it.
Yeah, no problem.
Thank you.
I have a question. So, would you put the joules after that? Or?
Yes, thank you for reminding me. Boop, that's my answer, right? So, this is a big one for you guys forever for the rest of your life. We will almost never, except for maybe on this first quiz, have numbers without units ever again, okay? We will always be working with real quantities that have units, and so your answer without the units will be considered incorrect, right? You also get partial credit, but just get in the habit of always putting the units down there. Absolutely. Great point, Sadie. Thank you. Other questions? We cool? Should we do some more practice? Cool. Let's do... Let's do 7C from the homework. So that was 7A, right? Now let's do 7C. Oof. Come on. So 7C, we have 13.1 miles, which is abbreviated MI. And we are converting to kilometers. It's already set up there for you, so it's pretty straightforward. But I just want to make sure that you guys are comfortable with the fact that even though the notation in 7C is a little bit different than the railroad track method that we were talking about, they're exactly the same thing, okay? So, railroad track-wise, right, we would, if we were going from miles to kilometers, we would need to go miles. Oh, you guys can't see that, can you? We would need to go miles to feet to kilometers. So what unit would go on bottom? Miles. What unit would go on top? We're not making a straight jump, right?
Feet.
Feet would go on top, right? So for every 1 mile, there's 5,280 feet. Miles cancels with miles. And then over here, what unit do I want on the bottom?
Feet.
Feet. And on top?
Kilometers.
I'm going from feet to...
Kilometers.
I just said that.
Oh, I'm sorry. I thought you said miles. I thought you said miles. Sorry. Perfect. And so for every... Oh, I didn't do it that way here. But we can. Oh, I just made this a lot harder. Let's do it the way that the problem does it in the book. We could do it this way, but it would be like 3 more steps, okay? So, let's go kilometers up top. And, oh, they're going to meters. I'm so sorry, you guys. This is a hard thing about looking at multiple screens at once. So I've got miles to meters. I'm going miles to kilometers to meters, right? Now all of these factors were given to you, so it's just a matter of figuring out how to set them up. So I'd want kilometers down here to cancel with kilometers up here, and meters up top. So I would have 10 to the 3 meters for every 1 kilometer. So what do you guys get when you put that in your calculator?
I got 21,077.9. So it'd be 2.1 times 10 to
2.18?
Yeah, 2.18, yeah.
Cool. Times 10 to the 3? Times 10 to the 4?
4, yeah.
4, thank you. Everybody comfortable with that? Sorry I wrote the problem down wrong, you guys. It always helps when you write the problem down right. That always gets you farther faster. Questions about that one?
No.
Cool. So this technique, dimensional analysis, is one of the most powerful problem-solving tools that I've ever learned. I think doing it in this kind of simplified fashion maybe makes it look like, why are we bothering to do all of these steps when you could just multiply things together and not think about the units. And that's totally fine. But what I can tell you is that when we get into word problems, which is our next step, is moving into word problems, it becomes much more difficult to see where the units are and where your conversion factors are, or how to map from one place to another. And so that's why this technique is so super duper important. Practicing it when it's easy will help us be more successful when it's more difficult. Okay, so let's do problem 8 from the homework.
I have a question on that one real quick.
Yeah, go for it.
I don't know if I'm putting it in incorrectly or what, but I did the 13.1 times 1.609, and I'm getting 2107.
Me too.
So it would be rounding to 2.11, not 2.18.
Yes, I agree. Yeah. That was probably just me misinterpreting what Ross said. Sorry about that, guys. Yeah, that's great. Thanks, guys.
All right, awesome. Thank you.
Yeah. Other questions?
So do you want all those answers in scientific notation then?
Yeah. So when you're looking at a number like this out of scientific notation, I would say that's pretty ugly. So if you were looking at a number that was like 15 meters, right? That you don't need to put into scientific notation for me. It's harder to put that into scientific notation than it is to just leave it as is. Does that make sense? Cool. Yeah, I know that this is a stupid rule and it doesn't help you at all, but mine is if it looks cuter in scientific notation, do it that way. If it looks more complicated, then don't do it that way. So.
So question.
Yeah.
Whenever you multiply the 13.1 times the 1.609,
Mm-hmm.
do you also multiply the 10 to the third power?
Yes.
I don't know if I'm putting it wrong, but I feel like I'm getting something different.
What did you get?
I'm thinking right now. I get like 21077.9.
That's the same thing that we got, but this is in scientific notation.
Oh, and then you just okay.
Yeah.
So I just gotta put in 5.
Yeah. So it's the same number that you're getting, but we just rounded and put it into scientific notation. Yeah.
Okay, I see it. I was like, why am I not getting it?
Nope. You're good. You're on the right track. Questions. I'm sorry. I'm just now looking into the chat. So Serena, if you had answered out of scientific notation for that 0.015 liters, I would have still given it to you unless I explicitly ask you to put it into proper scientific notation. Then I might mark off like half a point or something like that, right? Any other questions that I'm not addressing or that I haven't addressed yet? Coolsies. Okay. So, number 8, and I can't spell it all, you guys. What's this? Do you guys know what this is generic for?
It's Tylenol.
Tylenol, exactly. So if any of you guys have kids, this is a real conversion that I've actually done for figuring out how much medication I should give to my daughter. So the recommended dose is 15 milligrams per kilogram of body weight. How many milliliters of the suspension should be given? Of this suspension should be given to an infant that weighs 14 pounds. Yeah. So, any of you guys intuitively like, I know how to solve that problem? Cool. If you are, you're a wizard, okay? Because I don't think that this is intuitive at all, guys. So the first thing that I always do whenever I'm trying to solve a problem is I want to identify what information I'm given, right? So I'm given, numerically speaking, I'm given this number up here, right? there's 80 milligrams of Tylenol per 0.80 milliliters of the suspension. Does that make sense, guys?
Yes.
I have 15 milligrams per kilogram of body weight. So that means 15 milligrams of Tylenol per kilogram of body weight. Now, am I given the body weight in kilograms? No, right? That would be too easy. I'm given it in pounds, right? So I know right off the bat that I'm going to need to convert lbs to kilograms, right? I'm going to erase this because it's I need all this room back, but any questions about what we have written here? Cool. So, one of the big things that I want to point out to you guys is in written problems, word problems, a lot of the times you'll have scenarios where they're talking about milligrams of something, but the milligrams don't have that something attached to them in the problem. So it's difficult to figure out, okay, who does milligrams belong to, right? Does that make sense? So I have milligrams and kilograms in this problem, right? But they belong to different things. Does that make sense? Milligrams is acetaminophen, aka Tylenol, right? Kilograms is the weight of the child, right? So I know that may seem really annoying to point out, but I have to write down the complete units, otherwise I'm going to mess up this dimensional analysis. So I'm going to rewrite these in a more detailed form. Right? I have 80 milligrams of Tylenol per 0.80 milliliters of suspension. I have 15 milligrams of Tylenol per 1 kilogram of body weight. Now, it didn't say 15 milligrams per 1 kilogram, but I think it's helpful to put the 1 here as a placeholder, right? Is everybody comfortable with that? Cool. And then I know I have 14 lbs. Oops. So, now I can lay down my railroad tracks. I'm missing one factor, and that's getting me from lbs to kilograms, right? I believe it's 1.6 lbs. Other way around, sorry.
I looked it up as 0.453592.
Which to which?
1 pound would be 0.45 kilograms.
Right. So another way of saying that is 1 lb is 1.6. I'm sorry, vice versa. I keep switching these around on you guys. I'm sorry. 1.6 lbs is equal to 1 kilogram. It's not exact, but it's in the ballpark. And again, you don't need to memorize these. You would be given these factors. So, what unit needs to go on the bottom here?
LBS.
LBs, right? What unit's going to go on top?
Kilograms.
Kilograms. And specifically, I'm going to put body next to this to remind me that that's kilograms of body weight, right? And I have my conversion factor 1.6 lbs.
Sorry to interrupt, but Google says 1 kilogram is 2.205 pounds.
Cool. Thank you. Did I do it right that time? Thank you, Troy. Cool. So, I've got kilograms of body weight now, which I've converted into. And what's the problem asking me to solve for?
Milligrams per body weight?
Is it milligrams or is it how many milliliters? Milliliters of the suspension, right? So we're trying to get to milliliters of suspension as our units, right? So what unit needs to go on bottom over here to cancel with this guy?
Kilograms.
Kilograms of body, right? And looking at our conversion factors that we have up here that we're given, which one has kilograms of body in it? This guy, right? Is everybody cool with me? So for every 1 kilogram, I have 15 milligrams of Tylenol. Now I'm going off the board already. What unit needs to go down here?
Milligrams.
Milligrams of Tylenol, and what's going to go on top?
Milliliters.
Milliliters, right? I'm going to rewrite this in a nice way down below. Is everybody comfortable with what we did there?
Yes.
Cool. I'm going to rewrite this, make it cuter.
Are you able to just flip the fractions around like that?
Yes, totally. Yeah, so that's something that I think often students are a little uncomfortable with is how am I allowed to take this and flip it over? But it doesn't really matter how I use that ratio, right? As long as I use the correct ratio and all of the numbers that belong together end up together in the problem. Does that make sense? So like 0.80 belongs to milliliters, right? So what do you guys get?
getting 0.95 milliliters.
Mm-hmm.
I just want to make sure I'd be putting it in the correct order. Would it be 14 divided by 2.205 times 15 and 0.8 divided by 80?
Yes.
Okay.
For those of you who have to take off, this is going to be recorded and on Canvas, so don't stress out. So I would literally put this in my calculator as 14 times 15.
Can I interrupt real quick?
Yep, go ahead.
Before you divide by 80, make sure you times it by 2.205. If that clears it up.
Right? That's how I would put that in my calculator. Yeah, with parentheses on top and bottom, right? I think we talked in the math review a little bit about the fact that the parentheses on top are not as important as the parentheses on bottom, right? But it's good practice just to always have both.
Okay, thank you. I think I was just making that a lot more difficult than it needed to be.
When the units are all there, it looks uglier, right? So what I usually like to do is set up the dimensional analysis, knock down all of the stupid units until I get the unit that I want, and then rewrite it down below here with just the numbers, right? But what I really want you guys to take away from this, what I want you to get is that that was a really complicated problem, right? I think hopefully looking at that, you know, you guys might not have been confident, but once we wrote out all of the units completely, right, we can use the units to solve this problem. And we're going to do a lot more of this. Questions?
Thank you. Rewriting it like that helped a lot.
Yeah, totally.
Probably as like a helpful thing is maybe put milliliters on the top just in case if you forget
Oh,
to
yeah.
add it.
Solid.
You know what I mean?
Yep, totally.
Yeah, that way if like there's any confusion of what unit there is,
Yep.
it's right there
I
for
like
you.
that. I like that, Ross. That's good.
Awesome.
Any other questions about this? Cool. So, so that was about as complicated of a problem as you're going to see. Okay, so that number 8 on the homework, I would say, is probably one of the more complicated ways that you could see dimensional analysis. So if you can do that, then you can do whatever is going to be on a quiz or an exam. Okay.